Good afternoon. I had a few technical difficulties there kicking the stream off. For some reason, it kept jumping around between the different views I've got set up on my broadcast software. But we seem to be back in sync again now. So, what I'm actually going to do today is go through some details about Diamanti and Spectra 3, which was released recently. It was just at the beginning of last week. It was released, so some quite interesting stuff to know about. So let's look a little bit more about Diamanti and what Diamanti is about, and also about Spectra and what that gives you. So first of all, what Diamanti Spectra is doing is it's surpassing majority of the industry's abilities with multi-cluster, multi-cloud Kubernetes for stateful applications. If you're not familiar with the term stateful application, majority of applications that were first developed in containers for Kubernetes were stateless. So the actual application was a like web-based application, but it wasn't holding any data at all and wasn't modifying data at all. That data was somewhere else, a part of another part of the application set. But with this new version, what we can do is actually provide a multi-cluster and multi-cloud environment. So you can have multi-clusters on-premise in different sites. But you can also use a variety of public cloud services to run Kubernetes as well, which makes it much more flexible in the way that you deploy that, but also gives you the ability to manage stateful applications. So you can actually have persistent volumes of data that can be associated to specific applications, and that data is persistent afterwards, so it stays when the application is shut down if it needs to be, or if it's expanded, that same data is spread across multiple application sets. So giving you a lot more benefits, and from a development perspective, a lot more flexibility in the way that you deploy your applications. But also, it's a secure multi-tenancy environment, which gives you a lot more flexibility in the way that you deploy your application sets, because you can actually set up different tenants. So that's different development groups for a DevOps environment, or different parts of the business if you want to separate it out within the business, different departments. Or if you're a service provider and offering managed service to a customer base, you could actually split it out into different customers into their own tenancies. Each of those tenancies also has administrator, and then beneath that they can actually split that out into clusters and projects. So clusters could be different cloud providers, public service for Kubernetes, or it could be some on-premise infrastructure using the Diamanti technology. So that gives you a lot more flexibility, and also it gives you a lot more optimization in the way that you actually deliver containers and Kubernetes-based environments across your infrastructure. Finally, multi-site application resiliency. So a lot of people have struggled with how you actually protect the data that's within a clustered environment within Kubernetes or other containers. In a traditional enterprise environment, we're quite familiar with using software or hardware appliances to actually back up, provide that disaster recovery capability for application sets within a virtualized or a physical environment. Whereas containers have always been a little more challenge. How do we copy that data to a secondary site? How do we ensure that we can automatically switch to that site if we have a disaster to be able to recover from disaster? So again, with version 3, we've got some additional capabilities around setting specific objectives for applications and the recovery of those applications between sites. And that could be between sites or between clusters that are sat within a public cloud environment, no matter where. Let's look at the building blocks that makes up a Diamanti platform. There are three real components of this. It is a bare metal solution, so you get near 100% of the performance out of the underlying hardware, rather than if you go down the traditional hypervisor route using something like VMware or Hyper-V as environment to hold the applications. You're going to lose between 5 and 15% of your performance, at least, just to the hypervisor. With this, you're getting much more of that capability. So Spectra is the top level management and control section, utilizing Docker and Kubernetes to be able to give you that container environment, and also gives you a lot of the access controls and management of that infrastructure. The next piece is the breakout of networking and storage using Diamanti Ultima, and these are using PCIe cards to give you acceleration around storage and also networking. If you look at the more modern public cloud providers nowadays, most of them have separated out storage and networking from the rest of their compute components. It means you can actually accelerate that storage and also accelerate the network side of things and ensure you get really good performance, but also protecting it as well. And finally, at the bottom, you've got a couple of options which we'll talk about in a little while, but the Diamanti D20 is actually a modular 1U rack mount appliance that can run the Diamanti platform, so you can run containers across that whole platform using those three components. But there are also options to use other hardware vendors such as Dell or run the actual Diamanti platform. And the Diamanti Ultima cards can be installed in majority of those components. If we look at the way things have moved, originally people were using stateless applications, so there were basic web-based applications, and the data didn't matter. And if you look at the way that containers operate, especially when using Kubernetes around pods, if you did lose a particular set of containers, they would automatically restarted somewhere else within the cluster by the pod. So you'd always got that availability and also that disaster recovery from an application perspective. When we move to stateful applications, especially those basic ones that we started with, we need to find some kind of storage medium that we can keep the data for the applications within and be able to mount that data against those containers. As we move forward into this more complex stateful application, it's more around the persistence of that data, performance of access to data and the actual performance of the containers, but also the security of them as well, which is quite critical. If we've got that data there available to the container, it's another point that it could be compromised. So we need to ensure security at that point as well. And what we're seeing is a great change between moving that early days of stateless web-based applications being delivered through containers. People are now delivering more complex ones. And things like artificial intelligence and machine learning capabilities are being delivered through these kind of applications. And also we've seen a large number of people utilizing databases. One of the cases for using Diamanti is actually for Kafka. So Kafka running in a traditional environment, you cannot always get the best performance. Actually running under Diamanti, under that bare metal piece on a D20, you're going to see sometimes up to 4 times the performance you on traditional infrastructure for the same Kafka application set. So some real benefits in moving across Diamanti. So let's look at that, multi-cluster capabilities. So one of the key things with having this multi-cluster environment is that flexibility about the location. If you want to run the applications on-premise, you can. If you want to run them within a cloud environment from something like Microsoft's Azure, or you want to use AWS's platform, you can. But also we're looking at resiliency in these. So once we've actually spun those applications up, we need to make sure that we can protect them. So one thing is taking copies of the data, but also having copies available for disaster recovery, be able to seamlessly switch over to those disaster recovery pieces. Also, lifecycle management becomes into this because we're not really in the old world where we spend large amounts of time developing an application, testing it, and then deploying it. More if not now, we're in a DevOps environment using agile process for development and moving through those development stages then into production and then changing that production as we move forward into operations is a key thing. And this gives us a lot more control over that, so we can actually create different projects and different project administrators and then have applications within separate projects on different clusters. We can control that as well. Also, that multi-tenancy gives us some control over who can see what application, who can manage that application, rather than giving people access to everything that's on the. If we look at the situation we were in prior to the version 3 release, most organizations could actually control the failover of application sets in a container environment by utilizing some of the basic capabilities in Kubernetes, setting up the pods with pod replicas, so that if one failed, it would restart somewhere else and we quickly. The biggest issue, though, was how do you actually manage those data volumes, data that the applications are consuming or creating? How do we, one, give it access to those and keep it persistent, but also when we move to a failed environment, from the failed environment to the disaster recovery environment, how do we ensure that data is in line and also that it is in sync as well with the application, which is a bit of a challenge. So with the new solution, can do is replicate that data to that new environment, whether that's a cluster running D20 appliances or whether that's moving into Microsoft Azure, into the data store there, and ensuring those containers can spin back up when there is an issue and retain state and also deliver the service that we'll do through the applications. With the environment, we can run a variety of versions. So we can run Kubernetes, we can run OpenShift, we can use traditional application catalogs to deploy and manage the actual life cycle of the application sets. We've also got that disaster recovery piece we talked about to ensure that we protect those applications. Within that cluster management, we've got our cluster runtime, we've got updates and upgrades we can carry out without disrupting the container-based applications, and we also can give policy-based access to it, like I talked about a few seconds ago. At the bottom end, you've got the Diamanti D20 appliance, but you can also have your own infrastructure, so you can run within certain guidelines traditional hardware that you want to choose, but also then the public cloud providers. And across that, we get device management, security, and integration between those environments to make it fit together nice and seamlessly. So if we wanted to create an environment for an enterprise or an MSP, what we can do is create a tenant. So a tenant would then have a number of projects and also project admins, also tenant administrator. So you can create multiple environments across the same set of clusters and share that infrastructure across different groups of people within an enterprise organization, or you can actually do it within a particular customer within a shared piece of infrastructure set. That's across all of that physical infrastructure that could be on premise, but also that infrastructure that could be out in a public cloud environment. And from the customer's perspective, it doesn't look any different to them in the way that they manage that infrastructure. Same, giving lots more options for people to and use containers within their application production. Hopefully it gave you a good intro to what we can do with the Diamanti platform. It's quite new to a lot of people, but one of the key things is containers are not easy to actually deploy and manage and operate. A lot of people have gone down the route and tried to do it themselves using distributions of Linux and build it out themselves. Using Diamanti, you can actually speed up that process. We can commonly get a cluster deployed within around 15 minutes, and you can have applications time. A couple of key things about the actual infrastructure. If you go down the D20 route, you're getting NVMe, so you're getting very high performance for those application sets on there, but also you've got that control of the structure through the Diamanti platform. Be very interested in knowing what you think to Diamanti. Next week we're going to invite a couple of guys from Diamanti to talk a bit more about what Diamanti can provide, and hopefully you'll get to see the value it can bring to your organization. Thank you very much.